Right. Is it okay? Cool. So really sorry for the delay. Let's start. It is sharing screen. So I'm really bad at this job. Okay, share screen. Here it is. So yep. Come back. Never mind. Hard for me to get full screen, both of them. So welcome to this office hour session about using Kubernetes in Jenkins. So I will quickly introduce myself. So I'm Nicolas Delorf. I'm working at CloudBees for 4 years now. I've been contributing and maintaining the Git plugin for a long time. I've also created the build flow plugin. Maybe some of you did use it. It has been inspiration for the workflow plugin. I'm pretty proud for getting early on this topic. I also created with Johan a plugin we named Okidoki during the last year Docker Global Hack Day, and this plugin has been rebranded as CloudBees Docker Custom Build Environment. So that's a long name, but we noticed that it was really hard for people to find this plugin in the update center due to its name. I'm maintaining the Jenkins official Docker image, and I'm a Docker fanboy. So I will start with a short introduction on Kubernetes. Kubernetes is a way to pronounce the name of this project. It's a Greek noun. It means the sailing master, and it's about managing a cluster that will host services and containers. So project was created by Google. Google is a very early adopter of a container. They actually introduced control groups in Linux kernel in 2006. So they are using container for a long time. And they also are using actively containers. As you can see on the slides, they are running billions of containers every week, starting ton of them every second. So they are mostly using services that are long-running containers and also smaller just tasks for short period execution. Kubernetes was inspired by Google internal infrastructure. The initial one was named Borg, and then they had a new infrastructure project named Omega. They are published paper on this topic. Kubernetes actually reused the same concepts and solutions to provide what they consider to be the best possible way to host microservice application based on containers. So this includes container grouping, load balancing, scaling, and so on. We'll explain further. So the key concept of Kubernetes is first that application is not just one container, but in most cases a set of containers that only makes sense when run together on the same node, on the same host. So if you are already using a microservice architecture, that's typically what you expect. So they have this concept of pod, which is a group of containers that need to run together. You can use labels to define the role of each pod and interact with them. There is also, as we are talking about the cluster, what they call a kubelet, which is a node that is enabled for management by Kubernetes. Your pod also only makes sense if you can control the number of replicas you will have of it. Typically, a web application may need to run with 3, 5, or 7 replicas to absorb the load. Some database will need some replicas to ensure failover and so on. So it's the role of the replication controller. And on top of it, you can define a service that will be used to handle everything about HTTP traffic and so on. And there is for sure an API endpoint, so you can interact with the cluster. So we'll just show you the current cluster I'm using. So if you want to experiment with the Kubernetes, you can directly use Google Container Engine to set up one. I created my own cluster from the project source because I needed to tweak the Kubernetes minions to enable some advanced options. So as you can see here, I have 4 minions, so 4 nodes to host my Docker containers, and the master used to interact with the cluster. So there is a minimal UI where you can get some metrics about what's happening on the cluster, loads, and so on, but that's not really the topic for this session. So let's now talk about Jenkins in this specific context. So Carlos created a Kubernetes plugin. So was 1 year ago, if I remember correctly. So it's really, it's still an early stage development. Current release is 0.2, and I think Carlos wants to release 1 so we can make a reasonable demo during Jenkins user conference. So this plugin implements the Jenkins Cloud API, so it can provide executors on demand interacting with the Kubernetes cluster. So just before I show you Kubernetes in action with more detail, I will quickly talk about Google Container Registry. So for my demo, I have this Jenkins master running, and I am using a combination of, oh, sorry, I'm logged out. So I expect you don't use such a bad password on your production system. So I'm using here a custom Docker file to define the Jenkins slave relying on GNLP, Java Web Start, to connect to my Jenkins master. And it will be published on Google Container Registry, which is a private Docker registry hosted on my Google account. So here is the URL of this Docker registry. I'm using my Google account to log in. So with the adequate plugin setup, you can really have very simple Docker build and publish job configure. And this one will already run it, so nothing very interesting here. So Docker build, doing everything you can expect from a Docker build, whatever, and then pushing to GCR. So the main interest here, if you host Kubernetes on Google infrastructure, is that you will have the minion to pull the Docker image very fast because we are running in the same network. So Kubernetes main use case is to provide elastic slaves. It also lets you manage the Kubernetes command line interface. So you can manage your deployment on Kubernetes, interact with the cluster, and it also provides some workflow support. So let's see this in action. So here I'm using the Game of Life project. So here it is. So the one you can see from the Jenkins definitive guide. And I'm using a label, so I will use a specific build node with label cube. So we'll first take a look at my node configuration. So this one comes from the cloud. here it is, sorry, from the cloud template, which is configured to access Kubernetes. So here is my API master. Here is HTTPS certificate it's using and administrator password. So I'm using mostly everything by default. And for this specific demo, I'm using Docker in Docker, so I have to hack a few the command to use to start the slave. So that's it. And the reason I need Docker in Docker is that I'm not just using Kubernetes to host an executor on the Kubernetes cluster, but I'm also inside this container running a nested Docker image that will do the build. So I'm using the official Maven image, which is also maintained by Carlos, who is really deeply involved in this project. So we'll run Maven install. That's it. So these second options come from the CloudBees Docker custom build environment. So I can use whatever slave I have and just ask it that the build step itself is running inside a Docker image. So when we start to build, the Jenkins Cloud API will provision a new executor on my Kubernetes cluster. It was really fast, at least this time. We can have a quick look here. So this node has been started by Java Web Start. And I can share a console with you. I'm sorry, I have to change. Here it is. kubectl. So here are the pods I'm running. So this one is a slave that was just been created. So we can see a very classic Jenkins slave running with lots of dump trace from the Docker execution because we are using Docker in Docker. Possible improvement I'm considering is to be able to collect those pods logs. So you just you can have some better feedback on what's happening when you provision a node. As you can see, it was really fast. That was the reason I'm using a Google Container Registry, so I don't spend time pulling the Docker image. But sometimes it can be far slower. And so on the node itself, so it's running Maven at this time, they're learning everything. And the interesting part is at the beginning, where it's pulling the Maven image to and creating a container to host my build. And then every command I'm running, so the shell script I've configured to run my build, is actually run inside the container using Docker exec. Right, so no need to really spend more time on this one. So a second sample of what this plugin can provide is interaction with the Kubernetes command line interface, kubectl. So for sample, so we don't need SCM for this one. For this one, I can register the server endpoint and credential to be used, and it will set up Kubernetes config file, so I can directly run the adequate commands. So for example, here, I will just run a new application based on a single container. So that's That's a shortcut notation when you have a very simple task to run, and you don't need to define a pod with a set of container and a replication container controller and so on. So also for the same reason, you can use this exact same shell script to manage everything on the cluster from within your Jenkins CI system, being from continuous delivery, management, or whatever, and still benefits from credential integration. That's it. And last, this one is integration with workflow. So here I'm using a file, a workflow file stored in my project SCM. So I'm using the Jenkins file convention. And here it is. So I'm just doing the checkout from PetClinic project, then running the build inside Maven official image, so Maven package. I'm building a Docker image to include the WAR I just created. So I'm building a new Docker image that I will store on my Google Container Registry account. So I'm using Docker workflow support, so I can use image, I can build image, I can interact with the registry, I can push my image to the registry, and so on. And the last step is to use the Kubernetes build wrapper that you have seen as from a freestyle job. It can be used as well in a workflow with same parameters, your server URL and the credential ID, and just deploy this application. So we can give it a try. And if I'm lucky enough, I won't have a file system issue like 2 hours ago. So this one was the Maven build. So nothing really surprising so far. Then we're creating the Docker image with this new version of the WAR packaged into a container image. The Kubernetes setup do define everything about my configuration, setting credentials, selecting the adequate cluster, and so on, and push the application. So I can see here I have the application deployed as a new pod on my server. So I can't show you the application running because I haven't set up the firewall rules, so we can see the actual UI of PetClinic, but I guess you know Ruby about it. So what's next on this specific plugin? So first thing is we still need to polish and stabilize. So Carlos just noticed a regression I introduced recently. So was able to fix it yesterday. So thanks, Carlos, because my demo wouldn't work without your assistance. So there's still some room for improvement in terms of stability and also maybe some features. Have you seen on the global configuration for the pod templates? Here it is. We have some minimal setup for the Docker image to be run with some advanced setup. So today there is only option to run in privilege mode. Could be more in the future. But as you are understood, a pod is not just one container, can be a set of containers. We still have to understand if this can have any benefits in terms of Jenkins slaves. Maybe have a generic slave image to handle the remoting stuff, and then have some more project-specific container running side by side and sharing file system to actually host the build. I'm not sure what's the correct direction to go. Clearly, there is lots more to be done to benefit Kubernetes. Today, we are just using it to run a single container for a build. So probably some things to be experimented on this topic. Volume persistence is also a major issue when you build with Docker containers, because as you can imagine, if you ask the cluster to provision a container for a build, you will end with something that is fully isolated. That's a very good point. But on the opposite, you will end with a volume that is empty every time you start the build. Because your file system, your container file system isn't persistent as long as you start a fresh new container for the next build. So the way Docker does address this is to define volumes that you can bind mount into your container. So for example, you can ask the workspace to be bind mount into your container. You can ask the Maven local repository to be a bind mount into container. But when you start using a cluster and not just a single Docker host, you will need some way to ask the cluster to run on some specific node, or maybe the cluster can have some network storage service to interact with your container system. And so far, I haven't seen a very clear global solution for this issue. There is some dedicated tools, but they are not used by default in Kubernetes. And it's a major issue when you want to use Docker for Jenkins build within a Kubernetes cluster. So more to come on this topic. There's also a small design issue with the plugin. The very early development was using an obsolete Kubernetes client library. So we moved to Fabric 8, which is the recommended Kubernetes Java client. But this library has a major drawback because it's relying on a recent version of Spring, and so it's incompatible with dependencies we inherit from Jenkins core. So plugin has to hide parent libraries, and it's becoming a very huge file just because it duplicates lots of dependencies with the distinct incompatible versions. So that's a big pain. And something I'd like to experiment is to move to a lighter client, API client. And I just got some suggestion to use Swagger auto-generated client, because the Kubernetes API is documented with Swagger. So it's really simple to just generate the client as part of the build for the target API version, and use this plain client without so much dependencies. So something also to experiment and maybe make the plugin lighter and avoid to bundle 100 megabytes of dependencies in a single plugin. And also something that you didn't see on this demo, because the executor, the Kubernetes executor, has been provisioned very quickly. It was a good surprise. But when I start a fresh Jenkins master during development, or I notice some significant delay to get an executor provisioned, the reason for this is that the plugin is using Jenkins Cloud API. This API has been designed to manage virtual machines that are heavy to provision. So it's implementing some complex logic to determine if there is need to provision a new VM and when to stop it, considering that you are trying to reuse a VM as much as possible, and maybe to wait a few before you provision a fresh new one if some executor become available in the meantime. But when you consider living in a container world, you really don't need this logic. Containers are really light to set up, and you expect them to run only for one specific build. So at the exact time that your job enters the build queue and is ready for execution, you should have the executor being provisioned, and just after the build complete, it should be destroyed. So I'm looking into another way to implement such plugins, and I have a proof of concept. I'm working on a proof of concept. So far, it's just really minimal, but for sure this will be open source, and I expect Kubernetes plugin could benefit this approach if it's demonstrate to offer better results. Right. That's it for me. If you have any question, I would be happy to try to answer them, or any remarks or on. Oh, I can't hear anything. So we'll just check on Twitter. If I have someone. So I have a question from Cyril. He's asking the recommended approach to customize build environment with Kubernetes. Either using the underlying Kubernetes container or by using Docker calls within the job. I really think both make sense. So the first option is to define a new Kubernetes pod template to match your need with a specific Docker container, Docker image. So main issue doing this is that one, you need to be Jenkins administrator to do this. And the second one is that you need your Docker image to be designed to start a Java Web Start slave. So that's probably not the Docker image you are using on your laptop during development. But that's a reasonable solution if you have some limited set of build environments that you want to control on Kubernetes. The other option that I've shown using Docker custom build environment, sorry, cloud-based Docker custom build environment, what a long name. So this one is can benefit both approach. That means that you have just one single pod template to run all your slaves. This is a minimal one. And then you will start a nested container that can be anything to execute your build. So don't need to have a JVM, don't need to run Java Web Start, SSHD, or whatever. Main issue, if you want to do this on Kubernetes, is that you need Docker in Docker. And that means that you need some tweaks on your Kubernetes cluster to enable privilege mode. I wish we could interact with Kubernetes to run this container side by side with the slave agent and not inside as a nested Docker system. But so far, I didn't find the correct API to do this. I have another question about customizing Jenkins build environment with Docker. Do you recommend a fat general purpose Docker image with all tools or a smaller dedicated images? I think lots of people that start to use Docker will prefer the first approach because they will be able to set up a Docker image that match most of the use case they have in the company with the recommended runtime version and so on to probably match what they are running in production. And then they probably will move to another model when they want to have more control of what's happening in the container, maybe restrict to something lighter, maybe also want to use more recent version of runtimes and so on. That's the exact same issue you have with your production when you start using Docker. In many cases, your sysadmin team doesn't want to run whatever Docker image you can give them. They want a subset of recommended and curated images. And as long as they become confident with Docker, with the way people do write Docker files and use it in the company, they will let you get more flexibility. So clearly for immediate adoption, I will choose the first option to say, let's use Docker for isolation. That means you don't need to care about port used by your test, for example, to run Selenium and things like that. You don't need to be the sole one running on a build slave to avoid port conflicts. And you can come with a general purpose build image. And so another question is about using a second Jenkins Cloud Slave API for ephemeral slaves. Yeah, that was the point I had just earlier about Cloud API. I really don't think we need to replace the existing Cloud API that perfectly makes sense when you talk about virtual machines. So for example, if you are running your build executor on Amazon EC2, when you start a VM, you will pay for 1 hour of it, whatever you do with it. So it makes sense for this VM to stay online for at least 55 minutes before you shut it down. But in a container world, you will have other constraints, and you will expect other behavior of Jenkins. You don't expect it to wait for anything when the job enters the build queue. Just want it to start the container immediately and to assign the specific container to your build. No need to reuse it because it's really lightweight and better isolated to just start a fresh new one. And if you start to use dedicated Docker image for each job or if each team or whatever, it will make more sense to be able to just pass the Docker image as part of the build configuration. So I really think there is room for 2 distinct API. Maybe we will be some ephemeral slaves or container slave or Docker slave or whatever slave you want. But that's, for me, that's clearly a distinct way to manage executors. So don't really fit into the existing Cloud API. Right. I can see further question. If you have any, feel free to tweet me at Ndeloof, Ndeloof, because I can't see anything in the chat, but I'm not really used with Hangout on Air, so maybe I'm missing something. I just get a question from Carlos about using Kubernetes and Okidoki. This famous plugin that has been renamed with an infamous long name. As you've seen during the demo, I know it's working as long as you get Kubernetes running in privilege mode. But having discussed about Docker and Docker with Jerome Petazzoni, who created this hack, it's probably not the best option. Definitively not. What I really would like to is that the executor, the slave executor container that is running Jenkins remoting, that is probably doing the SCM checkout, can ask Kubernetes cluster to run a side container with shared volumes. Maybe for this to happen, we need some callback to Jenkins master or whatever technical details, but would clearly offer a better solution. And last but not least, if you want to know more about Kubernetes, I invite you to join Carlos Sanchez during Jenkins user conference next week. He will give a talk on Kubernetes and maybe even do a release of the plugin so you can experiment on your own. So if you don't have more questions, thank you guys for your attention, and feel free to ping me on various medias, including Jenkins user and Jenkins developer mailing list. Thank you all.